Okay, chapter 1.3, using midpoint and distance formulas. Essential question, how can you find the midpoint and length of a line segment in a coordinate plane? What you will learn in this chapter will be find segment lengths using midpoints and segment bisectors, use the midpoint formula, and use the distance formula. Okay, so let's just jump right in. Okay, so let's take a look at the core concepts first, midpoints and segment bisectors. So the definition for the word midpoint, the midpoint of a segment is the point that divides the segment into two congruent segments. So in this first diagram, segment AB, the midpoint is the point M. And it says the midpoint, or M is the midpoint of segment AB. So since it's a midpoint, it cuts the segment into two congruent segments. So AM, segment AM is congruent to segment MB. And that's what these little red marks are here and here. Those mean that they're the same length. So AM, segment AM is congruent to segment MB. And AM, the length of AM, so when you always say the length of, when you see two letters without the line over the top, you say the length of AM equals the length of MB. Okay, so the midpoint separates the segment into two congruent segments. And a segment bisector is a point, ray, line segment, or plane, can be any one of those, that intersects the segment at its midpoint. It's called a bisector, segment bisector. A midpoint or a segment bisector bisects a segment. Bisect meaning to cut into two equal pieces. And so now we have in this diagram segment AB and a line CD or line DC or line CM or line MC or line DM or line MD. Okay, you can name a line with any two given points in any direction, but they called it CD here. So line CD is a segment bisector of segment AB. So AM is congruent, segment AM is congruent to segment MB, and the length of AM equals the length of MB. So it can just be a point. In this case, this line bisects segment AB. So that is midpoints and segment bisectors. Okay, so example 1 says find the segment lengths. In the skateboard design, segment VW bisects XY. So let's stop right there and take a look at that. So VW is this line segment. And it's saying it bisects XY at the point T. And if you can't see this, it's pretty hard to see, but there are red marks here and here. That's the way we recognize something that's congruent. So therefore they have the same lengths. So V at W, the segment, bisected XY at T. So XT and TY are congruent. And they told us that XT equals 39.9 centimeters. And the question is asking us to find the length of XY. So from the last video, and you're going to hear me say this all year long, step 1, write a formula. So I'm going to say XY equals, and since I have a bisector, XY equals is the sum of its two parts, and its two parts are equal. So I'm going to say XY equals XT plus TY. XY equals XT plus TY. Now I'm going to substitute in my givens. XY equals, and we're given XT. So XT is right here, and it's 39.9 centimeters. So XT is 39.9 centimeters. Okay, but knowing that that bisects, we then can conclude that each piece are congruent. So since XT is 39.9 centimeters, TY has to also equal 39.9 centimeters. So I will substitute that in. And simplify. 9 plus 9 is 18, carry a 1. 9 plus 9 is 18, plus this 1 is 19, carry the 1. 3 plus 3 is 6, plus 1 is 7, and there's one decimal place. Centimeters. So XY equals 79.8 centimeters. So from here all the way to here is 79.8 centimeters. All right, example 2, using algebra with segment lengths. Point M is the midpoint of VW. Point M, midpoint of VW. When you have a midpoint, we then know that it is bisecting, meaning each piece is equal in length. Find the length of VM. Okay, so that's what we need to do. So I'm going to step 1, write a formula. VM equals the length of VM. Okay, so we want to find VM, but I don't have an equation for VM. I got thinking about that after, so don't write that. Write the whole thing. The whole thing, VW equals VM, that's messy. VM plus MW. Okay, so the whole thing equals the two pieces. But since this is a midpoint, we can do it this way. I'll do it this way, but we can also say, since that's a midpoint, it bisects them. I can also say VM equals MW. Okay, that's what these markers mean. So we have VM equals MW as well, and VW equals the whole thing. We're looking for VM. So if I just substitute in over here, we'll get back to this in a minute, but if I already know that this is the midpoint, then I can just set this equal to this. So VM equals MW. Substitute my givens. VM is 4x minus 1. That equals 3x plus 3. Now this looks like a simple two linear equations set equal to each other from Algebra 1. We then would isolate the variable and solve for x. So I'm going to move the smaller of the two. 3x is less than 4x. I don't want a negative variable, so I always move the smaller one. 4x minus 3x is 1x minus 1 equals 3x minus 3x is 0 plus 3 is 3. Then I add 1 to both sides, and I find out what x equals. It is 4. Okay, so now I say, well, VM equals 4x minus 1. And I know x equals 4 right here, so I'm going to take that x and I'm going to substitute it in right here. So VM is going to equal 4 times 4 minus 1. So VM equals 16 minus 1. VM equals 15. Okay, the length of VM is 15. Now I'm going to check over here. If I substitute in over here, 4 times 3 is 12, plus 3 is 15. So I get 15 again. So the whole thing is 30. So I'm not going to do it this way. I don't want to confuse you. Let's just leave it at this. We could do it that way, but whenever you have a midpoint problem, each segment is equal to the other. Both segments are equal, set them equal to each other, substitute and solve. Okay, before I do example 3, I want to talk about the midpoint formula. It's a core concept. The coordinates of the midpoint of a segment are the averages of the x coordinates of the and of the y coordinates of the endpoints. Okay, so let me go here, highlight average. Okay, it's a key component right there. The coordinates of the midpoint of a segment are the average of the x coordinates and of the y coordinates of its endpoints. Okay, so if A is the point x1. So here's A, the point x1 comma y1, which means I went over a distance of x and then up a distance x1 and up a distance of y1. That puts me at A. Okay. And then you take that and add, then you take the point x2, which is point B. So then if I go over to x2 and up to y2, that gives me the point x2, y2. And that is B. Okay, so x1, y1 is point A, and x2 comma y2 is point B. To find the midpoint, we add the x1 and the y1, I'm sorry, x1 and the x2 and divide it by 2. And they're showing us that right here. So x1 plus x2 divided by 2 gives us m. y1 plus y2 divided by 2 gives us the y value of m. So add the x's and divide by 2 to give us the x distance, and add y1 and y2 to get us the midpoint, and divide by 2 to get us the midpoint of the y distance. Okay, so let me erase all of this, and then I'll explain that with a number. Okay, so I'm going to make this value 1 right here, and I'm going to make this value 5. Those are my x's, and I'll do y's in reds just like they did. And let's make this 2 and make this, I don't know, 8. So I have the point 1 comma 2, which is A, which is right here, and I have the point 5 comma 8. Well, all this is saying is that x sub 1, my x of my first term is 1. So I'm not going to call that x sub 1 anymore. I'm going to call it 1. And so I'm going to put a 1 here. So that's going to be 1 plus over 2. And my x2 is 5. My x value of my second point is what that means, is 5. So that's 5. So it's saying x1 plus x2, but I'm going to call x2 5 now. It's 5. So 1 plus 5 equals 6 divided by 2, which equals 3. So that's going to give me my midpoint value of 3 here, because it's the average of the x's. I'm going to do the same now with the y's. So that's over here. So y1 is my y value of my first point, A, and that's 2. So this y1 is now 2. So this is now 2. And my y2 is my y value of my second point, which is now 8. So my y2 is 8, which would make this y2 8. And 2 plus 8. So then I'd have 2 plus 8 over 2, which equals 10 divided by 2, which equals 5. So my midpoint of this segment that has endpoints 1 comma 2 and 5 comma 8 is 3 comma 5. And the midpoint formula is simply that. Add your endpoints, divide by 2, do that with x, and do it with y. So with that, we're going to continue now on to the next example. Okay, so here we go. Part A, we're going to, using the midpoint formula, we're going to A, the endpoints of segment RS are these two locations. Find the coordinates of the midpoint M. So if I want to picture that and graph it, I could, but we don't need to. That's what's nice about the formula. So we're going to do it without. So the endpoints of RS are these values. So I'm going to label this x sub 1, and this one is going to be y sub 1. In other words, the x value from the first term, the y value from the first term. This is going to be x sub 2, and I'm saying sub, it's a subscript, x sub 2, comma, y sub 2. Those are my values. So the midpoint formula says that M, the midpoint M, is going to be the endpoints added and divided by 2. So it's x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. Okay, so m is going to be the midpoint of these. So now I substitute in my givens. X sub 1 is 1 plus x sub 2 is 4 over 2, comma, y sub 1, which is -3, plus y sub 2, which is 2. And that's going to be divided by 2. So my midpoint m is going to be the point 5 over 2, comma, -3 plus 2 is -1, 2. So the midpoint is the point 5/2, comma, -1.5. Okay, so let's graph that. Let's use Desmos and check it out. So I'm going to plot r, 1, comma, -3. So if I go into Desmos and I say, let r be the point 1, comma, -3 and hit enter. It's okay, it's not letting me put the letter R there. Let's do that. Okay, so there's R. Label, there it is. That's how you do it. I'm going to label it as R. Oh, cool. Okay, so there's R, 1, comma, -3. Let me zoom in so we can get the ones. There we go. 1, -3 is R. Okay, and S is 4, comma, 2. So I'm going to do 4, comma, 2, label it S, and behind my video. So here's R, here's S. So I could actually connect those and there'd be a line going through them. Okay, so I don't know if I can do a segment on here, but I can figure out what the line is there, and then we can find the midpoint of the segment. Okay, so I calculated the equation that would go through those 2 points. That's not important at this time, but there is the segment RS. What I want to do is find where the midpoint is. So if I go back, I got 5/2, comma, -1/2. So if I plug that into Desmos, and I do 5 divided by 2, comma, -1 divided by 2, and move that out of the way, then that is the point, and we'll call it M. And there is our point M. So RM equals MS. That is the midpoint. Okay, so I checked it on the graph. It does land right on the graph. So there is the midpoint of RS. Now we're going to do it again. Now we're given a midpoint. So you have to be careful when you're reading these. Now it says the midpoint of JK is this. One endpoint is this. Find the coordinates of endpoint K. A lot of students get really confused there. Here's what I suggest you do. Step 1, write the formula. Don't even think about what the problem's doing. Just write the formula. We want to find the midpoint. Actually, we're going to call it K this time. So find the coordinate of endpoint K. Oh, we want M. So M is, the formula for midpoint is x1 plus x2 divided by 2, comma, y1 plus y sub 2 divided by 2. And then I substitute in my givens. Well, I know M is the point 2, comma, 1. Okay. Okay, I'm going to change this a little bit. I'm going to put an equal sign here just to avoid confusion. So the midpoint equals this. So this is going to be 2, comma, 1. That is the midpoint we were given, M, and one endpoint. So let's call this, well, JK, let's call this X sub 1 and this Y sub 1. And we have to find X sub 2 and Y sub 2. So that's going to equal X sub 1, which is 1 plus X sub 2 divided by 2, comma, and then Y sub 1 is 4. plus y sub 2, which we don't know, divided by 2. So there's the formula substituted in. So then I can focus on this. This 2 right here is going to have to equal that right there. So I have to find an x sub 2 that would make that 2. So now I can break this into two different equations, and I'll color code these. And this is the y coming from this portion. So I'm basically saying 2 equals 1 plus some x sub 2 divided by 2. And I want to solve this for x. So I want to get rid of that 2. So I'll multiply both sides by 2. Well, that was weird. All right. I just got some notification and it changed the color of my pen. That was cool. 2 times 2. So 2 times 2 is 4. And these cancel. And that leaves me with 1 plus x sub 2. So if I subtract 1 from both sides, I simplify this, I get 3 equals x sub 2. So I found the x value of my midpoint. So I'm going to call my midpoint 3, comma, whatever I get over here. So now I have y is 1 equals this here, 4 plus y sub 2 over 2. Multiply both sides by 2 to get rid of that denominator. So these cancel. 2 times 1 is 2. And I get 4 plus y sub 2. To get the y sub 2 by itself, I subtract 4 from both sides. And that will give me negative 2 equals, these cancel, y sub 2. So my y value is 2. And that is the answer to my problem. Okay, so if I have the point JK, or segment JK, and its midpoint is 2, 1, and J is at 1, 4, then my other endpoint, it's not M, it is J. This is my J. Okay, J is 3, negative 2. Let me just rewrite that. And that is the answer to this portion of the problem. The point 3, negative 2. Oops, close my parentheses. Okay, the next core concept is the distance formula. So if you're given a point A with coordinates x sub 1, y sub 1, and point B, which are coordinates x sub 2, y sub 2, and they're points in the coordinate plane, then the distance between A and B is, so AB, the distance between A and B, or the length of AB, equals the square root of the difference between the x's squared plus the difference between the y's squared. Okay, so it's really based off of the Pythagorean theorem. And the Pythagorean theorem is simply a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse, or the longer side opposite the 90-degree angle. And as it says here, we'll work with those later in this course. But for now, what we're going to do is take the distance between x2 and x1, and that's how long that side is, and the distance between y1 and y2, and that's how long this side is, and that's what these are. And if you square them and then take the square root, that's how you find the direct distance at an angle, on a slant or on a slope between 2 points. Okay, so that's basically the distance formula related to the Pythagorean theorem. Okay, example 4 says, using the distance formula, your school is 4 miles east and 1 mile south of your apartment. So let me just draw a quick sketch of that. So let's just say here's our apartment. It is 4 miles east. Well, I brought this in here. East is to the right. So I'd have to go 1, 2, 3, 4 to the east. And 1 mile south, well, that's down. So 1 mile south would be right here. Okay, so that's your school. So that'd be S. So apartment being here, school being over 4, down 1. I'll do this in Desmos in a second. And then it says where your class is going on a field trip. Okay, your school is 4 miles east and 1 mile south of your apartment. A recycling center where your class is going on a field trip is 2 miles east and 3 miles north of your apartment. So then you start at your apartment again, and you go 2 miles east, which would be to here, and 3 miles north, which is up here. And that is the recycling center. Okay, so the house is here, school's here, recycling center's here. It said estimate the distance between the recycling center and your school. So the recycling center has a coordinate point of, if our house is at the origin, 0, 0, then R, the recycle center, would be 2 miles east, 3 miles north, and the school would be 4 miles east, 1 mile south, and that'd be a -1. Because south and west would be negative in this situation. So those are the 2 points that we're dealing with. So I'm going to do it without graphing first. So there's my little sketch of what's going on here. And we got those points from, I didn't highlight the others, 2 miles east, 3 miles north. That's the recycle center. And the school is 4, 1. Okay. So now it says, how far is R from S? So you would say, write a formula, RS equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so always step 1, write the formula. Step 2, substitute the givens. Okay, x sub 2. Well, let's call the school 0.1. And call it doesn't matter which one you do, the distance is always going to be the same. So let's call the school this 0.1. And R 2.2 comma 3 will be 0.2. Okay, think of it that way. And these x sub 1s and x sub 2s and all that is just asking what the x value from the second point is, what the x value from the first point is. So x value from 0.2 is 2, minus the x value from the first point, which is 4. And you square that. Plus y sub 2 means what's the y value from 0.2? Well, here's 0.2, the y value is 3, minus the y value from 0.1. 0.1's y value is -1. Watch the double negatives, minus a -1 squared. So RS is going to equal the square root of 2 minus 4, which is -2, squared, plus 3 minus a negative, which means plus 3 plus 1, which is 4 squared. So the distance between the recycle center and the school, which is RS, will be -2 squared, which is a +4, and plus 4 squared, which is 16. So the distance from R to S, or the length of RS, is the square root of 20. All right, so let's approximate that. So if we're talking perfect squares, the perfect square that's closest to 20 but less is the square root of 16. 4 is the square root of 16, and 5 is the square root of 25. So I know 20 is in between 4 and 5. So now I know that approximately it's 4 point some miles. Okay, and 20, the square root of 20 is 4 away from 16 and 5 away from 20. So it's really close to the middle in between of those two. So I would say RS is approximately 4.5. It's actually 4.4 something. Okay, and so let's now go to Desmos. And I could actually put that in, I believe. I think it calculates square root of 20. And there it is right there, 4.472. So we just rounded to 4.5. Okay, so now let's plot these and check and see. So we have a point 4,1. So I go to Desmos and I put in the point 4, 1. 4, 1 over 4 up 1 was the recycle center, I believe. Okay. And the school was the school's 4, -1. Let me fix this. It was negative 4, -1, and that is the school. The recycle center is 2, 3. So I'm going to put 2, 3, label it R. So we want to find the distance between. Okay. And I got, when I did this, I found the length to be 4.5. We could find the midpoint, but now we wanted to find the length. So what this really means is these two lines are going to come together at the point 2, -1. So I'm going to plot the point 2, -1 and enter. So now, as you can see, I would have a right triangle here. So to draw these lines, I could say x equals 2, enter. Oh, I can change that. X equals 2, and I only want it to go from 3 to -1, where x is greater than -1, but less than 3. No, that's not what I thought. That's not what it was doing. Step. Not sure what this means. X equals 2. Oh, no, never mind. If that said y, then that's, so let's not worry about that right this moment. So x equals 2 is this vertical line, and y equals -1. Okay, and then this line here, let me calculate that. Okay, so there's my right triangle I created. And just focus on the triangle itself, not the lines that extend beyond. I just graphed these lines and they all intersect and created this triangle. So here's our house at 0, 0. The school is 4 units, 4 miles to the right, south 1. And the recycle center was 2 miles east, or yeah, east, and 3 miles north. And what we just found was the distance between R and S. So this distance here is 4 minus 2, which was 2. And this distance here was 3 to -1, which is a distance of 4. So this is 2, this is 4. And if I go back to my work, okay, there's my 2, there's my 4. And I take the square root of those, and we got approximately 4.5. Okay, so we did the Pythagorean theorem. 2 squared plus 4 squared equals this squared. And you take the square root of everything, and you find that value, which is the square root of 20. Okay. Okay, that brings us to the end of chapter 1.3. These are the problems I want my class to do, so please go ahead and do those and have those ready for discussion in class. Have a great day.